This is problem 1127, integrated math 3, where you're asked to, in this case, subtract these rational expressions. Notice they already have the same denominator. So since the denominators are already the same, I could rewrite this as the same thing as, again, the denominator was 8x squared minus 50. And now I can combine the numerators together. What you have to be really careful with is that the 3x plus the 9, it gets subtracted the x plus 4, and this negative, it applies to both the x and the 4. So using parentheses will help so that you can actually distribute this negative to both of the two terms in this second fraction. So once I do that, I can simplify what I have on the top. Again, I have a 3x plus 9 for this first part, and then a minus x and a minus 4. And then again, all over that original denominator, which was the 8x squared minus 50. And if I think about continuing to simplify this a little bit and combining some like terms here, I've got the 3x here and a negative x, and those combine to just 2x's, and then the positive 9 and the negative 4, those constant terms combine to a 5. And in the denominator, I do have the 8x squared minus 50. But one of the things that we always want to check is the denominator further factorable, and could it at all cancel with perhaps the numerator? So I notice that 8 and 50 both have a 2 in them, so I'm going to factor out a 2 and see that I got a 4x squared minus 25. That remains. Now hopefully you recognize that 4x squared minus 25 is the difference of squares. So you can actually further factor the denominator. Again, in the numerator, I still have that 2x plus 5, but the denominator will factor into the difference of squares. Being if it's a 4x squared, the square root of that is 2x, so there's a 2x in the very beginning, and for the 25, the square root is 5. So again, both of these will be 5, but one will be positive and one will be negative. So that again, you'll cancel the middle term and have a negative 25. Now notice here in the numerator, this 2x plus 5, this linear factor will cancel with the 2x plus 5 in the denominator. And so my final answer here will be 1 over 2 times all we have remaining, 2x minus 5. And it would be fine to leave it in that form.